So we need to evaluate this complex expression, but let's start with just this part right here. Okay, what is the inverse cosine of radical 2 over 2? Well, the inverse cosine is an angle. It's the angle whose cosine is radical 2 over 2. So we have to be careful because there's more than one answer here. But let's go over to this chart. This is a chart that you should either have memorized or at least you have written down. So the cosine of what angle is radical 2 over 2 on this chart? So here's radical 2 over 2. So the cosine of pi over 4 is radical 2 over 2. All right, now that doesn't give us the final answer. That gives us what's called the reference angle. All right, the reference angle is pi over 4. The reason why that does not give us the final answer is because, okay, pi over 4 looks like this. Okay, each of these angles has a reference angle of pi over 4. The cosine of any of these angles is going to be some kind of radical 2 over 2. It's just that some of them are positive and some of them are negative, but all four of these angles, all four of these have a cosine of radical 2 over 2. Well, cosine is an x value, so cosine will be positive radical 2 over 2 in these two positions, and it will be negative radical 2 over 2 in these two positions. So in this case, we want a positive radical 2 over 2. So we can ignore these two angles. However, that still leaves two angles, all right? We've got pi over 4 and negative pi over 4. Okay? Both of these angles have a cosine of radical 2 over 2. So, which one is the right answer? To answer that, we need to remember that inverse cosine has restrictions. All of the inverse trig functions come with restrictions, specifically to solve this problem. You can't have a function that has more than one answer. So to narrow it down, they made these restrictions. So inverse cosine is only defined on the top half of the unit circle. So therefore, I can ignore the negative pi over 4 and just go with the positive pi over 4, all right, because we have to stay in the top half of the unit circle. So that means that the inverse cosine is pi over 4. Okay, but you really had to think through all of this. So we're halfway done. Okay, so now we found the value of this little portion right here. So now we can go ahead and write the rest of it. So now we have a cosine of, and then we have something minus pi over 2, and that's where the pi over 4 comes in that we just found. All right, so we just turned this into this. So now we have to keep going. Well, let's go ahead and subtract these two. All right, you know, we need like denominators, so we would multiply by 2 and multiply by 2. Okay, so this would be the same thing as 1 pi over 4 minus 2 pi over 4. So hopefully you can see that that's going to give you negative pi over 4. All right, 1 minus 2 is negative 1. So it's like negative 1 pi over 4. So we need to find the cosine of this. Well, now I feel silly for erasing the picture that I had before, okay, because now I need it again. All right, so this is a picture of multiples of pi over 4. So this is like positive pi over 4 if I go this way, and if I go this way, I'm doing negative pi over 4. So negative pi over 4 is right here. Okay, keep that in mind. Now, if I want to know what the cosine of negative pi over 4 is, I start with the reference angle, which of course is pi over 4. And I ask myself, okay, what's the cosine of the reference angle? Okay, we just discussed that. The cosine of pi over 4 is radical 2 over 2, or 1 over radical 2. So that's radical 2 over 2. So the cosine of negative pi over 4 is going to be the same thing, except for maybe it needs a negative sign. That's the only thing we have to worry about. All right, the cosine of any angle is the same thing as the cosine of the reference angle, except for you might have to change the sign. So the only question is, in this quadrant, is cosine positive or negative? Well, cosine is an x value on the unit circle. So x values are positive over here on the right-hand side. So this should be positive. So the answer should be radical 2 over 2. So the answer should be D.